Okay, this video is on Mohrs Circle. Here I have an element, and this is the orientation you want it to be in, where your normals are going to be positive. This will be your normal y and be positive, your normal x will be positive, and your shear is going to be positive. Now, you notice here on the shear, this one and this one is making it go back counterclockwise. If the orientation is this way, everything is positive. So using this, we'll look at this picture here. If I look at normal x is going to be positive. It's going to equal to 80 megapascals. Normal y will be negative. You can tell here that this one is making it go clockwise. Looking at this vector here. So our shear would here be negative. And this would be negative 40. I gotta write that a little bit better. Negative 40 megapascals. Okay, I'm going to delete this, just give myself a little bit of space. Alright. Now, to draw the circle, you're going to let your normal be along the horizontal. You're going to let your shear be on the vertical. Now the thing about shear is anything that goes down is going to be positive here. Anything that goes to the right here is going to be positive. Okay, so once you have that established, go ahead and find the center of the circle. The center is going to be located at where the average of the normal x and normal y. So average those and use the equation, just add them together and divide by 2. When we do it here, we'll get 80 minus 120. Divide that by 2. That gives me minus 40 over 2, which gives me a value of minus 20 megapascals. Okay, so we'll just do this. Our average is equal to minus 20 megapascals. Oops. Okay. Now we'll just delete this. Alright. So now what you want to do, you want to start here, and this is your 0, 0 point. You want to go to the left by 20 because it's negative, and right there we'll establish the negative 20 point. We'll draw an axis through there coming up. Move that around, get it right in the middle. I'll make that dashed and de-emphasize it just a little bit. Alright, so right there is the center of your circle. Now we want to establish the circle itself. So I'm going to come over the value of 80 from there. So I start from here, I'm going to go over 80. I come over from here and I put a mark right here. This value here represents the 80. I got negative shear, so I'm going to go up 40. And the reason I'm going up, because anything goes up is negative. So I put a dot right here. So again, the coordinates of that is going to be 80, comma, negative 40. From that point here, I will draw a line that's going to represent the radius of the circle. And to find that radius, we're basically going to do Pythagorean theorem. How far do we go over x? We're going to go 20 and another 80. That's 100. A little bit of delay here, so let me do it again. 100. How far do I go up? I go 40. So we do Pythagorean theorem. We'll take the square root of that. That's going to give me my radius of my circle. And when I do that, I'll write this over here. Radius using this gives me 107.7. Alright, so now erase this, and now we can draw the circle. Come into the circle. We take it here, we draw it all the way out to right there. There's the radius of the circle. Bring it out just a little bit. Alright, there's the radius. Now, your principal stresses are going to be located here and here. So that'll be your principal 1 and principal 2. Okay, now we can find these values because we know the radius. So to find this value here, it's going to be 107.7, which is the radius, and then we subtract the 20 from that. That gives us a value of 87.70 megapascals. We do the same thing over here. We're going to come back the minus 107.7 minus the 20 gives me a value of minus 127.70 megapascals. Okay, so there's our principal stresses here. Now this angle here represents 2 times theta of our principal stress. This angle right here represents 2 times our shear angle. So now if I want to find out the theta 1, I can say 2 theta principal 1. I'll do the tangent, sorry. Do the tangent. The tangent of 2 theta P1 is equal to the rise, and I went over negative 40, over the distance from here to here. And let me draw that as a line so we can see where that would be. There's my right angle there. So how far did I come over? I came over 100. If we do that here, that's going to give me a value of negative 0.40. So I can say that 2 theta P1 is equal to the inverse tangent of negative 0.40. We will get 2 times my principal. Give me a value of negative 21.80. So our principal would be equal to negative 10.90. So now that I have that, what this means is I'm going to rotate my element 10.90, and I'm going to do that clockwise. Because we had a negative angle here. So we'll draw our element like this. I will draw the horizontal line here going across, and now all I'm going to do is I'm going to take this element and I'm going to rotate it clockwise. That's supposed to be normal there, and I'll do that with a really light line. And this angle here would be 10.9. Now I can apply my principal stresses. I go back to P1, we had 87.7. You notice that is positive. So we'll draw this one coming out. Oops, let me get a vector, sorry. Coming out this way. You draw one back out this way. Again, those values are going to be 87. What was that? 87.7. megapascals. We have the same thing over here. Now we go back and we look at our principal over here. Negative 127.7. So since it's negative, it has to go in. And what did I say? 127.7. Yeah, 127.7. Okay, so that's my in-plane principal stresses. I will have no shear when I have it drawn in my in-plane principal stresses with the correct orientation being the 10.9. Alright, now let's go back and let's try to calculate what 2 theta shear is going to be. Okay, there's two ways to do that. The first way is we could just take 45 degrees, because we know our shear will be 45 degrees off of what our maximum principal stress is going to be. So we could take the 45, we could minus 10.9 from that if we choose to, and we'd get a 34.1. Now, if this one rotates down 10.9, the shear you're going to rotate counterclockwise 34.1. Now the other thing you could do would be to do the inverse tangent of this. Now we're going to do the inverse tangent of this. Sorry about that. Let me shut this off. The inverse tangent of this would be this distance here, which we said last time was going to be 100. So we could say, I'll scroll down to do that. Give myself some. I could say that the tangent of 2 theta shear is going to equal to, we said, would be 100 over what the shear is, and the shear here was minus 40 going this way. Okay, I'll get my calculator real quick here. Oh, sorry. So here, let's go ahead and rewrite this too. We want to say that 2 theta shear is equal to the inverse tan. And I'll move this up to be, well, I'll leave the negative down in the denominator. Typically you don't do that, but that's alright. 100 divided by negative 40. So when we take 100 divided by negative 40, we hit inverse tangent of that, and we will get an angle of 2 theta shear is equal to negative 68 point, basically 20. We divide that by 2, so we know our shear in this case would equal to negative 34.1. Okay, which you got exactly the same thing up there. Again, all that means the 34.1 is, it means we're going to rotate away from the positive shear, so we're going to go back this way here. So if I was going to draw that, then again I would draw my element like this. I'll scroll down and give myself some space. I would draw myself a horizontal line coming across. I would take this one like this. I'm going to rotate it up. And again, this angle here is going to be your 34.1. Like that, and you try and draw it normal to this surface here. And I'll make that negative there. Okay, and we would label that as 34.1 degrees. Alright, now we can go ahead and add in our shear stress to do that. Okay, to do that, we'll go back up to the picture, and the maximum shear stress is going to occur where this axis is going to intersect our circle, and we come down here. So the maximum shear at this point right here is going to be really what the radius is, and again this is going to be positive, sorry, this would be negative, so this would be negative 107.7 megapascals. Again, it's just the radius. This value here is going to be 107.7 megapascals. We come back down to our picture. We'll go ahead and draw these in. And we do, we'll have our coming this way. This will be coming back up this way. This will be coming this way. Oops. Sorry about that. Now it goes the other way. Goes back this way. This would be going this way. Now, remember this. When you have your maximum shear stress, and I'll go ahead and label those values as 107.7 megapascals, that this is where your average normal stresses will occur. We go back and remember at the beginning we found out when we averaged them we got negative 20 megapascals. So in this orientation, when you have the orientation of the plane for maximum in-plane shear stress, you have to always show the average. So this comes in, it only comes in because it's negative. Comes in all four directions. Coming in this way, and then coming this way. And these values here would be 20 megapascals, because that is your average normal stress. Okay, and that completes it. That's pretty much an orientation to Mohrs Circle. Pretty much just use the procedures that I'm demonstrating here, and you should be good to go.